In this module, we're going to be focusing on the first part of estimating the economics and the optimization of a chemical plant. So right now, parallel to the modules and the classes that we have been having, we're learning, right, using HISES, how to simulate a plant design. You're working right now on a particular project, and there you're learning how to design briefly, right, in an introductory level, how to design reactors, how to distribute the streams for the chemicals to go through their different sources and sinks in the process. You're learning how to match temperature and pressure. You're going to be learning basic separation train in this class. You're going to be learning how to do heat integration, and you will be learning how to do equipment design. Remember, this is all of it is happening in parallel while we're learning how to manage the economics of the process. Remember, optimization is just going back and forth between all of this. So this module, we're going to be focusing on fixed capital investment. So once you build the plan in your design, right, the next thing to do is to calculate the fixed capital investment or the fixed cost, and those include the equipment purchase costs, right, to know how much the cost of the equipment will be. That depends on the scale, how big the equipment is, and the time frame, right? If we're purchasing the equipment today, right, we can have values that are related to the present time. But if we have reference from previous dates, right, in the accounting archives or something like that, or we can have databases from the manufacturer, right, that they provide the cost per unit or scale. You can then consider time, right, because we expect inflation, right, and the economics is constantly changing, so the value of money changes from time to time. So then we, once we know the equipment purchasing cost, right, which is the base cost of that equipment, we can now think about the bare module cost, and we're going to see that the bare module cost just include the information about installation, the materials for installing that, the cost to ship that equipment from the place that is manufactured to our chemical plant, and there are other characteristics, right, that constitute the bare module cost. We're going to be calculating a bare module cost for each equipment because there's money needed to bring it to the plant, install it, and make it functional. And then we're going to be calculating as a whole, right, how much the cost of putting all the equipments in the plant cost, right? And this is known as the total module cost. And then if we want to include the plant and facility and ancillary spaces, right, that we need, like land that we need in the plant, then we calculate the grassroots cost. And we're going to see that these two numbers are, these three numbers, right, the bare module, the total module, and the grassroots cost, they are related. And we're going to be using equations and approximations to determine that. Then the third part, right, of designing the economics and optimization of a chemical plant is to talk about or to include the cost of manufacturing. And these are the annual costs. So it's like the fixed capital investment is just purchasing everything that you need to make your apartment operational. And then the cost of manufacturing involves everything that you have to pay month to month, right? The utilities, the rent, the cable, the Netflix, all of the things, right, that you need to pay every month or every year to make your apartment operational. So that includes the cost of manufacturing, includes the direct manufacturing costs like feedstocks, utilities, waste treatment, labor, and maintenance. Also includes general operating overhead expenses, and also include fixed costs that are associated to property taxes, insurance, and depreciation. Profitability will be seen after in the upcoming modules, and here we're going to get all of this information, and we're going to consider what we call the time value of money, Because if we design a plan today and we're going to be trying to find the profitability 20 years from now to compare the designs, we need to take into consideration the time value of the money. The value of the money changes. That's why we do investments, right? The investments that we do today are with the goal to see if we can earn some profit in the future. That means that as time passes, the money value is also changing, so we can get that payback, right, of the investment. The profitability includes earnings, the working capital, the fixed capital investment, right? We calculated. It includes information about the cost of manufacturing, and with all of this information, then we calculate different profitability measures that allow us to compare different designs and potential investments that we're working with. So optimization happens everywhere, right, in this process. In the early designs, we use heuristics that are based on safety, economics, and environmental concerns. We optimize there, right, only using parameters and the efficiency of performance of the plan. Then when we calculate the fixed capital investment and we notice that, for example, a distillation column end up being extraordinarily big, or we have a reactor that is very, very expensive because we're operating this at very extreme temperature and pressure, then we can go back to the plan design and optimize it to see if we can improve that. When we calculate the cost of manufacturing, for example, utilities, you can decide if you're going to use low pressure steam, medium pressure steam, and high pressure steam. You can also do heat integration and see if you can use the heat of hot streams to heat up colder streams in the process. And then with that, you create also optimizations because you're going back to the plan design. And when you do profitability, you can decide which designs that you're proposing are the most profitable and which one has the most potential to have profitability in the future, and therefore you can focus on working on the different areas. Is it the earnings? Is it the sales? Can we improve the sales? Can we improve the fixed capital investment, the cost of manufacturing? And we go back and forth between all of these aspects, right, of the economics of a chemical plant. So this is just an overview of what you're going to be looking at the upcoming modules. It's going to take us a couple of weeks to do this, but everything is connected. So the first step, right, once we design the plan is to deal with the equipment sizing and cost. We are really privileged, right, that our university has access to one of the best softwares out in the market. We are using the integration of economics in Aspen HYSYS. So if you look at your Aspen HYSYS, there's some boxes on the top, and one of them is economics. So what this does is that you can integrate your design and do some preliminary economics estimates. We also have the ability, right, like process engineers will do, to rapidly estimate the relative capital and operational costs in the process modeling studies. This brings the benefits of a software, right, that is embedded in the packet that you're installing in your computer, right, that is called Aspen Economic Evaluation product family. And basically this includes what is formally called as the Aspen Process Economic Analyzers, or IPEA, the Aspen Capital Cost Estimator, and the Aspen In-Plus Cost Estimator. The good thing is that every time that we update the software, like the version of Aspen that we have, and right now we have the latest version of Aspen, we are also updating the cost databases, right, and the VLE databases, and every information that is recent, right, in the literature and that Aspen has access to. So the main steps in the integrated economic evaluation are activating the costing engine, right? You're going to be doing your design and then you activate the costing engine. We're going to be mapping the design that you created with the ancillary softwares that you are using. So when you do the Aspen Economic Analyzers, you actually are using two softwares at the same time. You know that when you install this in your computer, you have a bundle. So it's a very big bundle, right? So you have multiple softwares working at the same time. So we're going to be in parallel using two licenses for each student every time that you are activating both modules. This mapping, right, would allow you to size the equipment and then perform economic evaluations and reviewing results. In our class, because I want you to learn how to do the calculations of economic evaluation by yourself. I don't want you to be dependent on a software. We're gonna really use from 1 to 3, and then number 4, it is available for us in Aspen. However, we are gonna do this ourselves using another software because I want you to see where the assumptions are, what type of equations you can use, so you can learn in the future that it really doesn't matter the software that you have, it's just understanding how the economic evaluation is performed. So the good thing is that the approach used in this technology, right, doesn't rely on capacity factor curves for equipment sizing, and we're gonna see that in some examples in this class. Nor does it rely on the factors to estimate installation quantities and install costs for bare equipment costs, which are the ones that we're going to use in this class. Instead, follows industry standards design codes and procedures to represent equipment with associated plan bulks and cost modeling and scheduling methods to estimate the cost of a project. In this class, we're going to learn what Aspen doesn't do, because if you do proceed to do this in the future, you will be able to learn what is in orange here, right on the right side. So I want you to learn the basics so you're savvy on how to do the calculations without the need of using any software, because you never know. Probably your company will not have access to this, so you may have access to other software. But if you know as a chemical engineer, you can translate those skills to any type of software. And the other thing is that the codes depend on the industry, and we're not going to have the time to get into the details for that, but it's going to be fun. So once you design your chemical plan, right, you're going to be mapping this. So mapping of each simulator model to one or more process equipment. We can then, when we map between the two software, the design software HYSYS and the economic software that is going to get that information. Notice here on the left how the icons look differently. The user, right, you can change, remove, and add equipment during the mapping process. So for example, in the left side, this module includes the condenser and the reboiler of the unit operation in HYSYS. However, the pumps are not there, but in the equipment model, we can actually add, for example, the reflux pump that otherwise is not there. Notice that here you just have the condenser, you're adding the reflux pump and the collector, right, the reflux drum to collect the condensate and send that back to the recycle. So we're able to add those two in the economic analyzer. So the sizing is performed using available simulation data, default sizing procedures that we're going to be reviewing in this class. Missing data is estimated by the system, which I think is a plus. Sometimes if you don't know what things are estimated, it could be kind of confusing. So we're going to be learning to document our assumptions and the defaults. The default materials of construction for all equipment is carbon steel, and this is what we call base conditions. And we're going to use this throughout the calculations in this class. The user, right, can review the sizing and materials of constructions, override estimated sizes, and enter values for on-site equipment. There's equipment that you want to add into the simulator to do the total cost, but maybe in your design you don't have it because it's already available in the process. So you can also do costing of things that you haven't simulated. That's also something useful about the software. So this is all of the things, right, that the activated economic analysis workflow does in Aspen. There's a lot of things, right, that you can see. However, we are going to focus on step 2 and 3, right? We're going to be mapping unit operations to process equipment, and we're going to be sizing and defining process equipment. The rest, we're going to get information about the sizing, and then we're going to use other models, the module, the bare module and total module techniques to actually evaluate the cost, the fixed capital investment, and the operational cost using our own equations. And once again, this is just for me to teach you how the code works behind the aspect, right? I don't want you to just be users of a software. I want you to be engineers and being able to translate all of this information to anywhere you work at after you pass this class.